Well, earlier we gave you a demonstration of the CamTrack program, and now I'd like to just give you a quick rundown of the essential code. It will be up on GitHub, and there'll be a link on that. So we'll just get started with the demo. First of all, I'd like to use FileZilla to transfer files from my PC to the Raspberry Pi and back again. And the reason I do that is because I can keep my files securely up on the NAS server and not have a problem if the Raspberry Pi has a problem. And also I can transfer it to another Raspberry Pi to test if I need to. So then if I open up my editor, I use Notepad++. I've just gotten used to it. There's other editors you can use, but you kind of get used to it. So this is the CamTrack program, and just a little description, some of the imports, some of the variables, the global variables for resizing and doing other things. In this case, you can see where I made the actual screen Opencv window twice as big, just for the purposes of the demonstration. You can flip, H-flip, rotate, and do other things. You set the frame rate. Okay, so Pi Video Stream is threaded video captures the Pi camera video stream. Just some procedures, or functions, I should say. This is the main part of the CamTrack program. This happened to be called CamShift when it's under development. This first part is just setting up variables before starting the loop. So the basic program, the meat of it here is to initialize. We take capture one frame out of the video stream, then we cut a specified NumPy array out of the main image 1, and that is called search_rect2. So that's a search rectangle that would be in the middle of the screen. So then we reinitialize the image because that's going to be the loop, and that will be the full-size image now. So now we have a template, a search rectangle, and we have a full-size image. So this match template is takes two main items. One is the large image, which is the full-size image, which is image 1, and the second is the clipped image, which is a NumPy array that represents what we're searching for in image 1. And these are some parameters that are required to do the procedure, the function. So now this returns a result which has to be processed. So we're going to process it with a min-max location, and we're sending it results. Now what it does is it sends the minimum value and the maximum value. Those values are between 0 and 1. So 99.99 would be a very high probability. So the maximum is the top returning result, and min is the lowest returning result. If and min location and max location are the XY coordinates of the locations of those best fit and the worst fit. So then, so the rest is just processing. Here we're just finding the center of that location, which is a procedure I wrote up above. Then we're just doing the mathematics to search for the, we're getting the XY coordinates of that result. Let me pull up an SSH session here. So this is the cam track. It might be better if I show you the results. Now this will stream by pretty quickly. Okay, so what we have is the cam is at 0, 0, and the two variables that I've got that are returned are cam track CX, that's the center of the image inside the larger image, and this is the Y coordinate, and these are the results. The XY, the largest is the 0.997, and the worst is 0.55. So I use that information in the program here. So what we're doing is we're taking the looking for a minimum value that's less than the min value, or sorry, we're looking for the location of the box of that max location, which is the XY coordinates. So 0 is the X and 1 is the Y, and we're looking we're looking for a location that's close to the edges of the full-size image, and that will trigger the camera to grab another middle frame, search rectangle, and the maximum value has to be greater than a specified amount. And then we look at the minimum value, and this determines if we're going to whether to take another sample out of the middle of the frame. So if you look at it, that's about it. The rest is just description. So there's really not very much involved. And this program can be used for, you could use it for robotics, for stabilization. If you have some moving platform and you have some servos, you can adjust the adjust things on the fly. So that's about it. The code is up on GitHub. It's kind of interesting to see the actual demonstration, but I thought maybe I'd just run through the code. So that's about it. Bye-bye.